Hey, usual. Nice to see you.
Uh, Good morning, sir.
Hey, you can just call me Mandar.
Okay, sir. Just for the sake of this session, I'll maintain some degree of formality for now.
Okay, sure.
Okay, so most of the students haven't joined yet, so it was supposed to be on 22 45. We advertised it that way. Until then, I'll be making you familiar with the format. So I have received some questions from the student side. So we'll be discussing those off, and then you can add on anything of your experience that you would like to share. And so, with your permission, are you comfortable with us recording this session?
Yeah, sure.
Or oh, okay. So I'll just hit up the organizer and we'll start the recording from 20 to 45. And until then, the questions are based on your experiences at your India, and then after when you did your masters. So we'll be starting from that.
Okay.
So if you have any questions. Okay, so we have started with the uh, session. So very good evening, guys. We have Mr. Mandar Deshpande with us. He's currently a engineer at Meta. In case any of you haven't done your homework yet, he has been a bachelor student in India, and then he went to pursue his uh, master's in UCLA in electronics and computer science. And then after that, he worked at Amazon, and then following that, he worked at Meta. So this is for you. Very good evening, sir.
Hey, everyone. Excited to be here.
And sir, do you have any special message for our students? All of us are BTech students.
I think it's just
So what do
exciting.
you?
Like, overall, there's so many things happening in the field, and the opportunities are ample. We see people are talking a lot about ChatGPT and all the AI stuff, but in parallel, there's also a whole field in accelerated computing, different kinds of applications we are going to start. Even quantum computing is going to catch up. So quantum computing might be a bit far off in the future, but accelerated computing or all these HPC stack, high performance computing stack like CUDA, GPUs, any custom silicon writing backends for them, that's going to be a huge field. So even I am excited for that and I'm investing my time in that area. So I encourage everyone to think about that area and see how they can make a contribution.
Okay, so but as you mentioned this quantum computing. So as a student, there are a lot of things like HPC and parallel programming yet to be explored by the students. But this quantum computing is a very new thing. So how can they start building concepts in that? Because most of us, they had our engineering physics in their first level exam. They learned some more quantum computing basis on that. But then there isn't any advancement in the world. But so how can they get into the quantum computing?
Got it. So there are two things over here. One is for any concept or any say new topic you want to explore, there's one which is called abstraction, where you're just using libraries or tools to build something. And then there is the actual science behind it, which you can call the implementation. So what you study in college is usually the implementation or like the science behind things. But when you step into the real world or like projects, if you're not doing research, you would mostly be doing just using the abstraction layer or using libraries like qubit like the concept called qubit or all these libraries built by IBM or say Google research or all these other people who are building things. So if I were interested in quantum computing, I would just go ahead and check out some tutorials, go through the basic concepts and try to build on top of them. Understanding the science is really important, but if you want to just build some applications or just see how these things work, simple tutorials can also help you over there.
Uh, yes, so that's very nice for to build start. Because these basics they help us a lot. Because and from basics, let us go back in time and start from the very first thing that you have in your CV. We went through all your GitHub profile. You must be having a lot of notifications nowadays. Okay,
Yeah.
so you managed to crack your GSoC intern in your bachelor year. So, and I believe that is the point where you started to develop a fondness towards this open source contribution and all of that things that led to what you are now. So, as myself, I aspire to be an intern at GSoC one day. So, how did you get uh, towards this open source field, and how did you choose your first contributions or your tech stack? So, could you please tell us more something?
Got it, got it. So I'll start a bit with the history as well. So I am an electrical and electronics engineer. I did triple E in my
Yes.
undergrad. So most of my friends or people I knew, they weren't involved in programming. The max programming we did was MATLAB for doing some simulations, and some of them were also doing chip design, like chip design as in VLSI or based on the courses, just what courses
Okay.
you did, what projects you had to do in that. People were doing those basic things like Verilog or doing MATLAB simulations. So in my first year, one of my friends, he was a mechanical engineer and he wasn't enjoying his coursework. I was still enjoying my classes. So he started doing
Okay.
C programming through this book called Let Us See by Yashwant Kanedkar.
Uh,
So I was like, okay, let's try it out. Even I started doing it. And then C, at that point, I wasn't aware. Neither I was using the internet very efficiently. I did not know what next steps I should do. Or Python also existed as a language. I did not know in 2013. So I started with what was immediately visible to me, which was app development, Android app development. So started learning about Android app development, did a bunch of YouTube tutorials, built some apps just from just like demo apps. And then one of my seniors, like final year seniors, they were starting a company called Rentartica, which is like a renting platform, and they wanted to build a Android application for it. So me and my friend pitched in that okay, we would help out with the prototype, build the front end and back end for it, and then just learn things on the go. Like we did not know Android app development as well, but we just did it on the go, and that gave me my first 5,000 or 10,000 rupees, I think. Like the first money I earned was in my second year. So I think that gave me a bit of a boost that apart from the core studies you do in college, there's also a whole lot of field outside in programming and app development. And I was still a very naive student. Like I did not know what all opportunities lies outside. So I still continued doing app development, web development, just the basic stuff, building web apps, all those Java and all the React wasn't a thing that time. Just build like JavaScript, Ajax, and all these very simple apps. Got an internship at City. Went there, realized that large scale projects have a whole lot of things which we don't know at all, and we need to learn them. So learned all of those things, came back, and at that point, one of my seniors from high school, he mentioned he was working on something called computer vision.
okay.
So
CV.
yeah, CV. So at that point, I knew about our Fourier transforms and all the signal processing stuff we learn in college, but I had no idea how this would turn into a real application. So again, went to OpenCV's tutorials, built some simple demos for face detection, hand tracking, all these different things. But there was no machine learning involved in any of that. Then
Okay.
just scrolling through LinkedIn, I realized people who do CV, like computer vision, also are exploring a field called machine learning. That was in my, I think after I did my third year internship. And then I came across Andrew
Okay.
NG.
So till third year, you were just into this development things, and then after that, you got into this machine learning and data.
Correct.
Oh. It's
Yeah,
still possible to switch after third year because most of the students they start with something and they are too afraid to switch back to things and give it a new start, but they don't realize that they are still in third year or say final year.
it's actually never too late to switch or change your domain. Even now, like I just switched my domain to machine learning compilers like recently. I've been in machine learning, computer vision, and all the application side of things, but now I'm moving lower in the stack. So I think in college, what we think about learning or ramping up or what new skills we need to think, we think in terms of tools. Tools as in, even I used to think in terms of Python. Say I know Python, I know TensorFlow, I know PyTorch. I used to think in terms of libraries or tools I know or technologies I know. But after a point, we realize that technology is going to come and go. What's going to stay is the problem solving skills, how you use technology, how you figure out which tools are to be used. That's more important than the actual tool itself. So, say somebody is doing web development or doing app development. If they are really good at it or they have spent the time to sharpen their skills, even if they transition to machine learning or they transition to, say, some other domain, the basic skills of acquiring new skills and learning and using them in some other context, they are going to be same, they are universal. So I think that's a key piece. It is never too late. Like when you are in undergrad, you still have a whole lot, your entire life ahead of you to explore. So I think just explore and try out whatever you want to do, because there are no consequences while you are still in college. But once you step out, those steps would be more, you would be more thoughtful in taking those steps, because your income is going to be based on that. Your family would want you to have something more reliable, and what risks you want to take. So that's going to change your trajectory.
Okay, just deviating slightly from the topic. You just mentioned this machine learning compiler. Could you please throw some light? I'm like genuinely this is my request to get something more about that.
Got it, got it. I think I forgot to mention about the OSS stuff as well. I'll talk about this after the
Okay.
compiler discussion. So machine learning compilers, example, we all know about compilers. You write some code, it runs on your machine, it doesn't run on my machine. So what's the common thing in that? It's usually a compiler which is going to convert your program into a generic format which can run on CPUs manufactured by, say, different OEMs. Now Intel usually
Okay.
makes a bunch of the CPUs, AMD might make some CPU, and you need these your program to be converted into something called assembly language, which the actual processor can understand. So even in machine
Okay.
learning, you might write any kind of model, you might write any kind of transformation program in PyTorch, JAX, TensorFlow, anything. It has to be converted to different backends. And backends is not the backend we call in app development. This backend is the actual hardware, CPU, GPU, custom silicon. Amazon is building Inferentia Trainium, Google is building TPUs. So all these different accelerators, similar to CPU, but they're doing specialized computation for machine learning. Like say they might have a unit on their chip for just doing tensor multiplication and addition. They might have a chip for just doing attention mechanism for language models. So all these different chips, they need the code to be optimized and then lowered to different intermediate representations, which then we brought to the assembly language in a format which the chip understands. So all this stack is called ML compiler. So you can go from PyTorch to assembly
Okay.
language, PyTorch to GPU to assembly language, PyTorch to CPU to assembly language. So all these different routes, and those are through a compiler.
Okay, the closest thing that I've been using is this torch.compile that
Yeah,
just is used to do the same stuff but on a higher level, I believe. Okay, now just slightly continuing this. What are the languages used in like industrial scale? Do they still use Python then they convert it into assembly or something like that? So how are things being done at industrial scale? For say some ML model, the task is to build an ML model. So do you still use Python or is it something else that we aren't aware?
yeah. Python is the most common thing because it's very easy to express anything you want in Python. It's similar to just our spoken English. So everything is authored, like implemented in Python. But when it runs in, say, a production server, when I say production, it's the actual use case. Say you are scrolling Amazon or you're scrolling the Facebook feed. That time Python won't be used at runtime. What they do is they would build any kind of application, package it in some way, or say I didn't talk about models because that's my domain, but say you build a machine learning model, you've got a neural network which is really huge. Now during runtime, if you use Python, it's going to be very slow. Its performance isn't
Yes.
really good at scale. So what they do is they author everything in Python and then they serialize it. Like serialize as in they'll convert it into a binary format which can be consumed by a C++ runtime. So most of your
Oh,
production use cases would be in some low level language like C, C++, or Rust is also catching up, but yeah, it's still very new. But usually all these runtime services are in C++, and then it would take that binary or like the serialized format of your model and serve the actual request you see with live traffic. So you are scrolling Instagram, there are hundreds of models running in the backend, but they are all written in Python by the ML engineers. But when they are running in production, they are in a serialized format, like a string format. They serialize into a binary which
oh,
can be consumed by a C++ service.
okay. I got it.
Oh, I think the screen froze.
You just mentioned Rush. So, is it important to know?
Hey, usual. I think your video froze.
Actually, we encountered some network issue. Just give us 2-3 minutes.
Yeah, sure.
Hello. So your mic is off.
Yeah, yeah.
Sorry, sir.
Yeah, that's
Actually, we are
okay.
doing this from hostel, so it's just encountered into a network issue.
Yeah.
Okay. So, huh. I was asking, okay, let's go back in time and go back to your GSoC period. So, how did you choose the uh, firms that you contributed in? Because before that, you need to contribute in something. And how, what was your tech stack until you got, like you talked about that, okay, you weren't introduced to ML and data science until you were in third year. So how did you manage to build up to that tech stack? And as a mentor, what did you see in the people's tech stack and contribution? What that made them special and eligible for this internship?
Got it, got it. So when I completed my third year internship, when I started fourth year, I just knew about, I think I mentioned about OpenCV, a bunch of computer vision, and I started taking this Andrew Ng's ML class. So that ML class was also in MATLAB, like it had you implement everything in
Yeah.
something called Skylab, or it called,
Yeah.
there's some other alternative to MATLAB as well. Scilab is one of it, and there is something else. I don't remember the name. Octave. Yeah. So that course had you implement all the assignments in Octave as an alternative. I did not have a
Okay.
MATLAB license. Most of the people in college just use the college license. So I started doing all the assignments, everything else, and realized that okay, Python is also really easy to do. It's just like it's easier than C or Java, which I've already learned for the app development. So let me just try it out. And learning Python doesn't take you that long. It might take you like 2 weeks, 3 weeks at max, because you don't need to learn it all. You just need to know how much you need to use. Everything else you can just search and then use it.
Yeah.
I started doing that, and then I think it was in I think GSoC applications open up in February of the year when the GSoC is like GSoC usually starts in May. Now they've changed the format a bit, but at that time it started in
Okay.
May and they opened the applications in February. So until that point, I was just playing around. I was using OpenCV, scikit-learn, Python, and some of the basic stuff which everybody starts with. I had no idea. Then I looked at all the projects listed in February on all the application pages. There were organizations like Red Hat, there was Skylab, GNU project, Octave. There were many other good machine learning libraries as well. Even like the library behind NumPy, like the umbrella called NumFocus, they were also having some projects like SkyPy, SymPy, all these different libraries were there. But what they required from the applicant was a very advanced knowledge of maths and actual machine learning, which I did not have at that point. I just knew the basics, but I did not have the confidence that okay, I'll be able to make an impact in those libraries. So I saw okay, which library is most aligned with the understanding I already have. I knew a lot about MATLAB. I knew something about machine learning, and Skylab was a good fit. It was like an open source alternative to MATLAB, provided the same similar toolbox or interface, though it was not as featured out as MATLAB, but it was free. So I thought, why not make a proposal to it? And I had a lot of projects and awareness of the MATLAB software tools to make an impact in the Skylab community. So I just went to their project repo, which wasn't even on GitHub. They had something called Forge, Conda Forge. If I
Okay. I haven't heard
maybe
of
Conda
it.
Forge. Yeah, yeah, yeah. It's a very different version control system. So I just went there and started looking at issues, made some initial documentation fixes, as everybody starts with, and then made some simple fixes like some numeric types are different, you need to fix them. Some C type needs updates in their backend, made some fixes to them. And then I submitted a proposal saying that MATLAB has all these toolboxes for running simple regressions, linear regression, logistic regression, or a bunch of simple machine learning models, no deep learning or nothing too advanced. We could build a similar toolbox for MATLAB, for Skylab. And yeah, that proposal got accepted. And then most of it I learned like building the toolbox, packaging it, and how do you publish it with the Skylab package. That was through the developers, core developers of Skylab itself.
Okay.
There were people in France, some of them were in Germany, and they helped me a lot. So they became like my mentors. In GSoC, you are assigned a mentor, but then there
Yes.
are a whole lot of people who you work with. They tell you how do you make these contributions, how should you structure your PR as in pull request. How do you write out the issue and describe the issues? How do you ask for help? So I think I learned a lot. Initially, I was very scared that they would think that I don't know anything. And how are they, like, am I even eligible for this project? But then over time, you realize nobody knows everything. You have to ask questions and keep moving. You ask questions, get help, and keep moving. Nobody expects you to know everything, but they want you to be proactive in asking for help. So I think through that I entered the domain, started building out the toolbox for machine learning or regression models within Skylab. And then in that journey, I realized scikit-learn also had all these different models or like algorithms to run regressions. Within regressions, you can logistic regression, you can have elastic, lasso, L1, L2, norm, all these different kinds of concepts I learned through that, plus what I had studied in the NGONG's course. So I continued doing that. And yeah, I think that was most of it. That was most of GSoC.
Okay, and what was your tenure as a mentor? Because you served as a mentor for 1 year for into 2019, I believe. Yes.
Yes. So I mentored for, I think, 3 years. Like in 2018, the project I did for Skylab, it was built out, but it was still running on your local machine. So in 20, I think even when I finished my project, I had a future plan for the project that if we could integrate it with some cloud providers like AWS, GCP, or Azure, that would be a really easy way to run models remotely. So say you are using Skylab on your local machine, but when you run the model, you don't have access to really high quality CPU or GPU. So you can abstract out all the execution to a remote machine on some cloud provider. So one of the students made a proposal extending that project, adding more features onto it. And then we did all the integration in 2018, integrated it with GCP and AWS. It was a standalone script and tool, so you could just start any virtual machine on any of these cloud providers and just run that script. It would set up all this remote connection between your local Skylab setup and a remote kernel, like a IPython kernel running on their server. So that worked out pretty well. Then at that point, I was working at City, so I couldn't do open source contributions. I wasn't allowed to make GitHub pull requests because City is a financial institution. They don't allow you to make a lot of open source contributions. It's very risk averse company or anywhere like they're doing finance related stuff. They want you to get approvals for everything. But I could still help out as in my capacity as a mentor. So I joined the NumFocus organization, which write like NumPy, SkyPy, SymPy, what else? Jupyter. That was also under NumFocus at that point. And in 2019, there was a project for TensorFlow, and I had some
Okay.
contributions in TensorFlow as well. They were building a reinforcement learning library called RL agents, TF agents, TensorFlow agents for uh, for Google Summer of Code. So me and another engineer from Google who was at Mountain View at that point, he was building the actual library. We mentored a student working at who was studying at Princeton on building that library. So I think that was also a good experience. And then it continues. Like once you gain the momentum, you learn a lot. Like even being a mentor doesn't mean you know everything. You're learning a lot of these things. You just need to know how to help people out and how to be proactive in identifying things which the student won't identify. So I think that helped.
Okay. And as a mentor, what did you see in people like you were meant people you were that were assigned to you as mentee? Do you recommend any special tech stack like apart from the critical thinking and this problem solving skills? Because
I think,
those are the foundations I believe that everyone looks out for. But apart from that, any special tech stack that gave them an extra edge or something?
I think one interesting thing I saw is like that wasn't the only thing I decided upon, but most of the students had their own projects going on, which wasn't attached to any internship or any immediate benefit. Like they were just exploring. They were doing their own projects on the side. And while doing that, it was clear that some of these people had an upper hand because they had learned the skills while building things. Say you build a web application and you actually serve it on github.io. Anybody can go there and actually look at your web app. So it's more tangible. Like people can actually look at it and believe you because you have shown them what you have done. Say I build a model, a machine learning model to do some regression. Now anybody can build it, but how do you present it also affects a lot. So some of these people had the projects, they had written out their own documentation, not extensive as you see in open source software, but simple documentation, readme files, how do you use their tools, how do you set it up, simple things. But they were aware about the basic stuff, and that gave them the platform to do even more complicated stuff. So I think that helps a lot.
Okay, and moving forward from this GSoC part that came in your life while you were still in your Citibank, and you worked there for some time in Pune, I believe, if my research is correct, and then you went to California to pursue your master's. So,
Correct.
what was this need that you felt for a master's degree and additional higher education?
So honestly, when I was in my final year, I was still thinking whether I should do a master's or not. But then at that point, my awareness wasn't enough. And everyone I knew mentioned that you're already in the domain, you're already getting into the field of machine learning. So it felt right to spend some more time in it, actually understand what all is out there, and then decide on the next steps. Maybe it was possible I never went for masters and started my own company in India. I don't know. And at that point, I was just, I can say I was a noob at that point. I had no idea. I was trying things out, exploring stuff, and looking at tutorials, building projects. So, City, why I stayed at City was that was my first exposure to all these large scale projects, how things go live, what's actually production launch, what all you do. And then while doing that, I realized that when you start working, you get all the money. You get enough money. You are staying all alone. You enjoy the freedom. You're away from home. You can do anything. Go on trips, buy anything you want, enjoy anything you like to do. But then after a point, it just gets routine. And then looking at everyone, there were people who were 5 years elder to me who had started as a new grad at City and they were still there. They were enjoying their life. But then I realized, do I really want to just do this or there is something else waiting out for me? So I started searching a bit. And then I realized one good opportunity would be to either switch companies or either pursue higher education. So higher education, I could have done it in India. There were a lot of great opportunities at IISc, even a bunch of IITs were doing great stuff in ML. But most of the advanced stuff, or when you want to explore things, they were happening in California or CMU or all these other universities over here. So I thought, let's give it a shot. I also interviewed for a bunch of startups, got into few of them, but then again, it's the trade-off between getting the immediate reward right now versus spending some time to explore and maybe getting the reward later eventually. So I decided I will not focus on the money part at that point. Convinced my parents. They were actually convinced, but I just had to tell them when I was going. So then I applied to a bunch of universities. I applied to a bunch of universities in 2018 and surprisingly did not get any admits. Like just got two admits, and I did not want to go to those universities. And then in 2019, I reapplied with all this city experience and GSoC stuff, and got into UCLA and UCSD. So decided to go to UCLA.
Okay. And this was and after UCLA you have written your thesis at UCLA. I read it, so I found it really interesting that these foreign institutions, they also promote research in their courses, while it's still something that is budding in my college. So but overall, speaking of India, they don't really focus on research especially in their undergrad. So, and do you think that research helps in getting a job, or is it any helpful for an undergrad student to put up some research work and give his time? And I'll come to next question after this.
Okay, yeah, sure. So I think research is it's a very interesting question. Even I have been on and off about my interest in research, like whether I am really into it or am I just doing it because it sounds interesting. So main thing I feel is if you really are interested, there are a bunch of people who pursue PhDs or they spend their majority of their careers focused on one topic or like diving into it, learning more about it, or really understanding the stuff rather than just using it. So you need to not do it just to say get into some university or get into some job. Don't do it for that because you would not enjoy it if you're doing it for some output at the end. You need to enjoy the process itself, like say research. So I don't think it's needed for a job. Like if your ultimate goal is to just do a job, it's not going to be needed. But research itself will teach you a lot of things because there are so many frustrating moments while you are doing research. You are just stuck. You don't know how to make progress. But that's also true when you're doing engineering. Engineering, as in not the college stuff, but software engineering or any kind of engineering in the real world. You will get stuck and you will not find a way to move forward until you just spend the time. So research is really good, but I think I'm not well equipped to advise in that area. I haven't spent a lot of time doing research.
Oh, and uh, apart from this, do you like still there are research based things in Meta, and there's this Google DeepMind project in Google, then there are Meta AI labs, and they are just focusing on research.
Yeah.
So do you what part of these corporation giants do research, and what part of these are focused on this deployment stuff?
Got it. So I can. So one of the things I worked at AWS when I did my original stint. I was a research engineer there. We were building a service called AWS Recognition, building anomaly detection models for all the conveyor belts. So what they do is they put up all these cameras in factories and they do fault detection on all the units. So they need to build models for finding out faults on chips, on packaged goods, or say things you returned on Amazon. People would package things which are not really the thing they got. And how would Amazon know? So they would run an X-ray on top of it and run anomaly detection models to figure out whether it's the real product or somebody has sent the fake item. So so there are labs doing research like this, but in every research organization, say AWS AI or like Meta's Meta's lab, FAIR,
Uh,
or Google
AI lab.
Deep. So all of them, there are few people who are doing pure research. They're usually called science teams, and then there are engineering counterparts. So the research teams would just be focused on exploring the new idea, like say this architecture sounds good, or this use case combined with this learning rate or this optimizer can give you this kinds of gains. They would be focused on building out these new models. And then there are counterparts on the engineering side who would take those ideas into real products or like real production use cases. So what I've seen is there are people usually on the research side, a lot of people have done PhDs and they are doing the fundamental science stuff. But a lot of people have not done even masters. They've just done undergrad and through different routes they have gotten into research. So main idea is to just to get into the field and be surrounded by people who are doing great work, and then you will automatically find what's your real calling. For me, I tried research for almost a year, and I realized okay, it's the pace is too slow for me. Like like to explore different things. Don't want to spend too much time doing just one thing, so I switched back to engineering. So I think you have to find that out, and that can only be realized with experience. Like you'll spend time and you'll realize, do you like this or you don't like this.
Okay, and there's this thing in the ML community throughout that. Okay, the most of the jobs are occupied are taken by people with PhDs and masters. So if you're taking ML as a thing in your bachelor's, then you have a lot of competition, not only in India but outside India. It's like it's more outside India because there they focus more on PhD than the master. But this field is, you know, the veterans are the PhDs and the master's holder. So, do you think is it still beneficial for student to take up ML and data science in their this undergrad and then go through all this competition?
So I
Like,
kind of
have
agree
you?
with this. I kind of agree with this, and it was true. I think 3 or 4 years ago, where most of these new roles were just being taken by PhDs because it was still a new field at that point. Like it was just in existence from 5 or 6 years at that point. But if you think about today, I think ML is democratized. Like you can learn about it, you can go to Hugging Face, try out the models, understand everything you need to do. And all the PhD folks, what they are actually doing is building the real models. That's just going to be 20% of the actual job. Like
Okay.
in, a, in any company, like if you think about Meta or you think about say AWS, Amazon, or all this, even OpenAI. I have people who work at OpenAI and they don't have PhDs. They have just done undergrad. They've just done masters. It's not needed. So main thing you have to realize is PhDs are doing some, not always, but when they are hired, they are expected to do fundamental stuff, build new stuff, which is not expected a lot of time from engineers. So anytime somebody is doing fundamental research, they are not going to be too focused on say performance, on reliability, how good the experience is going to be. All of that requires an engineer's mindset. So even at Meta, most of the people are just software engineers. And even people who are working as a machine learning engineer, machine learning might be 20% of their job. 80% is just regular software engineering. So even when I work on PyTorch, you need to understand machine learning. You need to know regression, deep learning, like basic stuff you need to know. That's the expectation. But that's not going to help you succeed. What's going to help you succeed is the software engineering skills, understanding how to structure stuff, how do you design stuff, how do you make good code reviews, how do you communicate with people. All those skills are essential. The research part is really, really very niche, but that gets the most publicity because that's easy to show.
Okay, so what I got from here is that undergrads should basically focus on ML ops. Their ML ops skills should be like top notch to get a job at a good firm because that's what's being used there.
I would say like if still it's really great if you can learn about machine learning, deep learning. The concepts are really important, but just those are not going to help you. See, getting a job and knowing the skill are very different things. Even say when I interviewed at Meta, what I interviewed for and what I'm actually doing is worlds apart. So I wouldn't say getting into a job means that you are eligible for it all the time. You need to have the skills to be good at it. A lot of people get in, but they can't actually continue being there because say doing lead code or knowing data structures and algorithms just one part of the interview, and in the actual job that's going to be like less than 1% of the job. So I think knowing machine learning, deep learning is really important, but knowing the basics of software engineering, like knowing how to use the terminal really well, how do you use git, how do you do all this editing, diffing? How do you make changes to the code? How do you iteratively modify a project? How do you plan for it? All those things are really important.
Okay. And in the starting of our conversation, we talked about this low level stuff that you are doing, and there was a mention of Rust that is catching up. So, do you think that as ML engineer or say meta engineer or as an any engineer, you need to know this low level languages and basics of computer science, like how things work?
It's not necessary, but it can be useful. So within software engineering, there are multiple branches, I would say. Depends on where do you want to go. Now I have friends at say NVIDIA who are building CUDA modules, so like CUDA kernels. Now, if they don't know about the low level stuff, then they won't be able to be good at their work. But say somebody who's doing app development, they don't need to know about CUDA or all the hardware level stuff. And then there are
Yes.
people working even on top of it, like someone who is a ML engineer. They only need to learn about, say, PyTorch, the concepts in machine learning, how do you build the models, what's the loss function, all those things. So it depends on which of these branches you go into. You need to learn different skills.
Okay, and what I remember from my research is that there was your collaboration with the Northwestern University. In they have this IBPL lab,
Yeah,
and you worked on some Pixel CNN. So, what were the insights from there? What were the challenges, say, in that project? Could you please mind sharing those?
yeah. It was a really great experience. So how it happened is I took a signal processing course on Coursera, and I messaged the professor on LinkedIn, like who was actually uh, like authoring that course, and he spoke with me on LinkedIn. I learned a bit, and he told me how this is moving towards machine learning, all this computer vision, and all that stuff. So there was a PhD student in his lab at Northwestern University who was doing this Pixel CNN project. So I messaged him and asked him if I can get involved. There was no monetary benefit involved. I just wanted to learn. So he used
Okay,
to give me like smaller chunks of tasks in his research, and I used to go ahead and implement them, writing some simple TensorFlow modules for doing, say, residual networks. Then we used to combine both of our work, and it wasn't, I can't say I did it to completion, but I was working with him for close to 6 or 7 months. So I think main thing I learned is his focus was on research and I was more on the implementation side. So he was the abstraction guy, I was the implementation guy. He used to have all the ideas and I was trying to get those ideas into code so that we could run them. So overall I learned is nobody knows everything. You need to still search, whether it's Google or ChatGPT now it depends, but you still need to search for things. You need to know where to search for things. That's also important. So over time, it's never going to be that you know everything about machine learning or Python or C++. That won't ever happen. But you would know what to apply when because you have all this history of building things and you can pick different blocks from your memory and then use them over here. So even in that project, that was like a learning experience for me. That TensorFlow is a really solid library. At that point, it was, and you just need
so
to know.
everything is being taken over by PyTorch.
Yeah, now PyTorch is the thing. Even Jax is catching up. Let's see.
And we are moving towards the end of the session. So before we do that, please, would you mind sharing what, like, how do you manage to contribute at PyTorch and all these big firms while still you still have your job at Meta and you still manage to do such wonderful things, and how one can choose to contribute the organization, like say I myself do this practice ML and make a few models here and there, but I really still don't know how to find the problems and be confident about whether I could be able to solve that issue or not. So how do you pick up the issues? That's the main point.
Got it, got it. So, like I can say, I'm fortunate enough to work within the PyTorch team. Like I work at PyTorch at Meta. That's why I'm able to make the contributions. Most of my work I do, part of it might be open source as well. So you might see it on GitHub, or some of this is internal, so it's not visible outside. But for anyone else, it's you have to realize that issues on GitHub, or say you go to the PyTorch repo, there's a bunch of issues which are tagged as
Yes,
low hanging fruit,
beginner and
beginner
yeah.
friendly. Every repo would have different tags. You need to pick them up, and they're not going to be really huge issues. Usually, what these projects do is they would break down a bigger problem into the smaller issues. Like, say, you need to go somewhere and change the D type, like data type, for some of the tensors from float 16 to float 32, for example, and that would fix the
Okay.
issue. So you have to realize that anything you find out, it's not going to be immediately clear that what's the solution, but you have to spend time figuring out, asking questions. People on GitHub are very helpful. Like, you can, on any of the issue you pick up, you can ask questions and people would respond to you. And then based on that help, you can start making simple contributions. Initially, it might appear very intimidating. Even now, if I say I want to go ahead and make a contribution to Hugging Face, I would feel a bit hesitant initially. But now over time, you realize it's a common thing. Every time you are trying something new, you will have that hesitation. But asking questions and asking for help is the way to go. Just look at those low hanging fruits, beginner friendly, or new contributions welcome, like all these kinds of tags, and just pick up the issues and start making contributions. Even if they are incorrect, that's okay. What's the max that can go wrong? They would reject the issue, right?
Yes.
They would reject the PR, like pull request. That's
Pull
all.
request.
Then you can pick up something else. So I would say, don't be too worried on deciding what to pick. Just pick something up and give your hand at it. Like, it would work out.
Okay, and another thing, like we would like to know a lot from you, but we are this having this time constraint. So you have worked for CV. I believe you must have some work something at for NLP, and then there are reinforcement. So what do you think the future is in like? Is NLP is going to be the big thing because everything is based on ChatGPT now?
Got it.
Uh,
So I think the way ChatGPT came out was through NLP. But if you think about the basic architecture, it's based on transformers. It's a very generic architecture. It doesn't need to rely just on language. It's called a large language model, but if you look at the transformer architecture, it is
yes,
just processing a
even it's
sequence of, yeah,
yeah, VIT's been there, and then there was a new paper last week that was processing audio based on
yeah,
this transfer. Yeah, and even
yeah,
time series data are now being processed in transformer network.
correct, correct.
So yes, transformer is the big thing we get here. But where does the future lie, like in the computer vision or in the NLP side?
I think the main future lies in unified models, like where they are going to have multimodal models doing things in different modalities. Like, you would have a bigger model. If you read about Google Pathways, they have a great blog about it. So it's a huge model, and they route different modalities through different paths within a larger model. This was before all this chat GPT and llama stuff came out. But even now, multimodal models is going to be a big thing. But if you think longer term, there would be a point where they would reach a wall. Like, they can't scale it beyond.
Saturation.
Yeah, they'll reach a saturation. Right now, they haven't reached that. They're still generating new data, scraping all the data from the net and adding more and more GPUs to their data centers. But eventually, they would come a point where they can't learn more from this given data. So some new architecture will come out. So I think right now is the best time to not focus on building the model itself, but on building the stack for the model. Stack as in, it can be accelerated computing. It can be, how do you set up training? How do you set up inference? All these different things have very specific libraries which are used to do this. Like Torch Compile is one of the tools which people use to boost the performance of their model at inference time. Similar to that, there will be new stuff which will come along. And I think if anybody who is starting out or still thinking what to do in this domain, I think accelerated computing is going to be big. Like CUDA being one of it. Then it can be writing QBLAS code, QDNN, anything which goes from Python to some low level language and then runs on GPUs or custom silicon, that's going to be really huge. Because it's natural, like the larger these models get, the more hungry for computation and data they are going to be. And that would mean you need more GPUs at the bottom. And these GPUs will only run some accelerated computing stack, whether it's CUDA from NVIDIA or ROCm from AMD. It can be either of these or something new, which is coming out right now. So I think that's a very huge domain, and not a lot of people are involved in that.
Okay, and now right now these companies are just in a rat race to build a bigger model, serve the company. So the all the essence lies in the optimization and
Yeah,
as a
performance and optimization is going to be very huge.
And okay, so we are getting towards the end, and we have some questions in chat. So I would be asking it, and please answer them if you don't mind.
Yeah,
So
sure.
we have first question. It's being asked by this Pranav Srivastav. He's in third year. He's saying that it was said that we shouldn't be contributing simple stuff on open source. So what's your take on that? Like if there is a product that's still in the build stage and then we are contributing simple stuff, so what's your take on that?
Simple stuff, like how would you categorize simple stuff? Is it like dog fixes or like adding new features? Uh, Depends. Like so, I would think as if something is in progress and the authors like who are building the library they don't want contributions, then I wouldn't force it upon them. But usually these bigger projects they have more issues than they have contributors. So I think you should find projects which have large enough scope and they have enough issues to solve rather than looking for some smaller libraries which are still building out. Because say some library which is just 2 months old, library or some GitHub repo is just 2 months old. The authors themselves are just figuring out what to do and they are getting contributions from outside. So it's a overhead for them to review requests and actually add to it. But it can turn into great opportunities. Like you can become a core contributor if you start early. So I think I wouldn't say no to it, but depends on what the owner of that repo wants.
Okay. And we have next question. He's Saksham Sangwan. He's still in first year, and he's asking if you could start and learn skills from scratch again. So how would you approach it? Because nowadays there are many resources that are available, and it's very challenging as a student to differentiate what's the best resource and what to go with it. So is there any specific advice that you would give him to navigate through this?
Yeah, I think one major thing is I spent too much time actually going through courses, like going through some of these courses which were great, like they are good, but they give you a false sense of accomplishment. Like you do all these simple assignments which are very easy to do, and then once you do the course, you feel like, oh, I really understand this stuff, but it's actually not useful in the real world. What I would do is I would focus more on building projects, even if it's not going to be used, but building something which is tangible. Tangible as in building a simple Android app and like side loading it on my phone or getting a developer account for say OpenAI's computer, taking the Meta Llama model and building something on your own rather than just doing courses. So in today's world, the great advantage is Hugging Face has all these models hosted on their Hugging Face, like the hub, model hub. You can go there, fetch any model, create a Hugging Face space, create your own demo over there. I would encourage students to do more hands-on project because I spent too much time doing courses and that wasn't too helpful.
Okay, and we have a question. There's this Rohit Chaudhary is trying to have a take. He is asking, Avesh organized an event where we were supposed to code addition using a neural network in C++. What do you
Hmm.
think was this event? Because he's asking whether was this event a success or not. But so let me modify his question for you. Okay, so at Avesh, we try to make students learn by doing, like you mentioned, and we focus things to learn from scratch because in C++ you can't really code and
Yeah,
have something as import torch and torch.n and things. So, do you think that this approach was very good or something like that? Because it was aimed at building concepts. Student would learn.
I think it sounds good to me. It would be good, but it has a lot of prerequisites. Like people should know C++, all this smart pointers for pointer stuff. So it depends like what audience you are catering to. Plus, if people already know if it's aimed at teaching machine learning, then doing it in C++ might be a bit of a stretch because it's difficult to abstract things out in C++. You need to know the
You
pointers and
need to
all.
know everything.
Yeah, you need to know it. Like that's the issue. So yeah, definitely
Okay,
useful if people are already
that's
aware. And C++ is not an issue. But if it's, then it's a good
easier
project.
task than it.
Yeah.
Okay, we have another question from Fresher. He's asking, how would you start your ML journey in 2024 if you were to? But so, are you a huge fan of reading documentation, reading books, rather than like going through the courses? Like you mentioned, courses are an waste of time. Not waste of time. They provide a very little hands-on experience. But do
Yeah.
you think books are way faster approach than this reading documentation?
So documentation and books both are very useful. Even courses are useful, but when you look at a video example, it's very slow. Like you're taking it really slow and you get this sense of accomplishment, which is not right. So I would say do both. Still, I would say students should figure it out in their own journey. Maybe something else works for you. But for me, text is very easy. You can scan through stuff. You can jump from topic to topic. You don't need to read a book cover to cover. You can jump to specific topics. You want to learn about fine tuning. You just read about that. You go to documentation. You just read about that. I think that's going to be useful. If I had to start my ML journey today, I would start by building something on top of Hugging Face because that's the way to go today. It's very accessible. Like that, what's it? That's their aim. Like they're trying to make it accessible. You just install their package, fetch some model, run it on your
Yeah.
local machine or on their faces, and from there on you can go towards the fundamentals. So, what I wouldn't recommend, I can't advise, but I can recommend is I see a bunch of people reaching out where they have built something on top of say LLMs, but they don't know how an LLM actually
What's
works.
the
Yeah. So I would say abstraction is good, but you still need to know the fundamental stuff because that's going to set you apart from the crowd. Otherwise, there's going to be thousands of people who are going to use it, and only like double digit people in double digits who really know the stuff happening inside. So you need to decide where do you want to be. And if you know both, then it's a
that's the best.
yeah, that's the best.
Cherry, cherry on top of the cake.
Yeah.
Okay. We have another question. What do you see the landscape of ML learning evolving over the next few years? What are the some exciting areas that you are keeping an eye upon in the research part? Like, what are the new things, new developments in AI? Because I can name a few, like AGI is like evolving quite fast. Do you think diffusion models would take over this transformer someday? Because for video generation, we still use rely on diffusion.
Yeah, yeah. I think diffusion models, they can work out. The only thing is whether they can scale. The thing is with transformers, you can stack as many units on top and it can just,
Attention heads.
yeah, attention layers. That's not the case with diffusion yet. I'm not sure, like I need to read more about it. But what I feel is even transformers isn't going to be the long term thing because the way it's scaling right now, people are just feeding it more and more data, increasing the number of parameters. But eventually, something much more simpler is going to come out, which is not obvious right now, but people would reach in that direction. In a way, this field is, I won't say saturating, but very few people are actually doing new stuff. So most of the stuff is now doing the engineering part of the research, taking those ideas into products. Google building all those Gemini APIs, Meta doing the Llama stuff, putting it into WhatsApp, Instagram, everywhere. So all these companies are going to build on top of it. The research part, all the research I am seeing right now, it's all based on transformers and all this
Transformers.
LLM ideas. They might do multimodal stuff. They might change the precision, like floating point precision, or change what kind of training they do, changing some learning rate. I can't see anything fundamental changing over there. But one major thing I have learned is if you have read about Tesla's autopilot, what they do is they do
Yes.
uh, training time versus inference time, they do different things. At training time, they also use lidar sensors and they do sensor fusion. So fusing information from different modalities into a common embedding or vector space and then using it to train the model. I think this is going to be even more common because you would have all these smart devices collecting all different kinds of data. There's also a company called Osmo building models which can digitize scent. So they can,
Yeah, I was aware of that. They use this peach smell, I believe, in
yeah,
their this demo, and
yeah.
then they showed.
So I think it's all,
That was really exciting.
yeah, yeah. So I think data and computation is going to be common. The architectures, they might come and go. You can pick it up. That's not going to be a challenge because before something is researched and it comes into the becomes a common thing, there's a delay of at least 1 or 2 years. Right now, it's reduced to 6 months because people are in a race. Maybe it's to the top or to the bottom. That's unclear right now.
Okay, and we have last two questions. So one question is, what advice would you give to someone looking to start with contributing to open source project like TensorFlow or Scilab? I believe we have given enough of advice, but just one small bit of golden words.
I would first through the documentation, just read what all things are there, go through their GitHub page or whatever, wherever they serve their repo. And they usually have a contributions readme. Like they explicitly mention how should you start contributing. Look out for simple issues. See if you can make some documentation fixes to start with so that you get familiar with the territory where the code is, where the documentation is. And then start looking for low hanging fruits. Look at the tags. And main thing is ask questions. Like just ask questions without hesitation and be okay with making mistakes. It's not going to be nobody's going to come and scold you. Nobody's going to fine you for making a wrong pull request. It's very easy to revert. So I think be more eager in making out the changes, even if they are not the most polished ones. You can always polish it based on what recommendations those reviewers give you. So I think start early and make mistakes. I think I would just suggest that.
That's the gist. And the last question from our side. So, as your as a mentor in multiple Google GSoC projects, what do you look for in mentees? We have already answered that. And how do you ensure effective mentorship in remote collaborations?
Yeah, even before.
That's, I believe, is all over the mentee, how frequent he's asking questions or how curious is he, or is it more of some contribution from the mentor, special contribution from the mentor side?
So it goes both ways. Like even I need to be proactive, or anyone who is, say, mentoring someone, they need to reach out with people and identify things because they have the perspective or experience. They have been through that same thing. They have been stuck multiple times, so they can realize, okay, maybe right now is the right point like, to suggest them a new direction, or maybe help them out with some complicated project they're trying out. I think main thing is having regular check-ins. What I did is I had a weekly, bi-weekly actually, twice a week I used to have a 30-minute sync up with my mentee. Even now, mentor-mentee setup is similar to how it works in actual work life. You have check-ins with people, you need to raise questions, and that relationship goes both ways. It's not always that the mentee is the one learning from the mentor. Even I learn a lot from my mentee, so you have to ask questions to them. I have to be updated and be on top of things. Otherwise, if things slip, if you are not aware, then people feel like they don't have a purpose. So you need to be on top and be more proactive in asking for help and providing support. Both things.
Okay, sir. That's the end of question. But this last question, he says that can you suggest some books or sources to start our journey? I believe sir has given enough of insights. But sir, is there still any book that you refer to, or it's just documentation at this point?
So I have this book called what's this book? Hands-on Machine Learning by
By Orally
yeah,
publication.
yeah. You might get it PDF format. It's very easily available. I have the hard copy
Yes.
as well, but it's a good book. Like it's just about the basics, but you can go back and refer to it multiple times. Even now, I refer to it. Uh, like almost every month, I just refer to it for some questions I get. You can always search the internet. Everything is very easily accessible, but some of these things are good if you have a single source of truth for it. So I think that's one of the good books I feel. One more thing I feel is when I was in my undergrad or even in my masters, I used to write down all the highlights of any algorithm, like any algorithm, just a one liner or the main concepts. Say for linear regression, y is equal to x plus c is the main thing. What's your
Yeah.
learning rate? Like, how do you learn actually? What's that formula? For logistic regression, what's that log formula? What's your form? Like the simple things.
Although
Like the thing is, some of these things you're not trying to rote learn it, but the more you go through them, it will just
understand.
be a part of you. You don't need to you don't need to think about it when anybody asks you or that topic comes out in some of your work. So I think writing down notes and keeping them handy is really useful. I think yeah, that's one more thing I would recommend.
Okay, so we are in with our questions now, and looking at the time, I believe we have crossed the required time limit. So, sir, any closing notes for this session for the students?
Yeah, I think thank you. Thanks, Ujwal, for hosting me, and thanks, Avesh, for this opportunity to speak with you all. I think main thing I feel is it's a really exciting time to be a student because the field is evolving very rapidly. One major thing I feel is don't be too scared to explore because you're still a student. And even I am very early in my career right now. I would say I'm still early in my career, so I'm still happy to explore. And you being a student, you should take that time and advantage to your benefit. So one major thing is college isn't the easiest part of life, but it also isn't the toughest. If you think about it, it's very difficult to score a 9 pointer, but it's also very difficult to fail, right? So to realize you always have these pockets of time where you can try out stuff, do a bit of exploration, talk to people, and use your network to your advantage. Keep in touch with your seniors who are actually working in the industry. Reach out to people on LinkedIn. Say the way Avesh or say Ujjwal reached out to me, I think it was okay. Like if you reach out to 10 other people, you reach out to someone from the OpenAI team, maybe they would also reply to you. So don't be hesitant. Like at max, what would happen? Somebody would say no to you, and tomorrow you would even forget that. So I think just take those chances, take the risk. Right now, there aren't too many consequences. Ask for help, and people would give you all kinds of good recommendations or advice. And use this time which you have right now to your advantage. I mean, it's unbelievable how people don't realize it. Even I did not realize it while I was in college. That's the best time of your life. You have the entire day to yourself. Classes are just one piece of it. Whether you attend them or you don't attend them, that's your choice. But the main thing is you have a lot of time in front of you. Use it to your advantage and explore as much as you want. Like try out all the different things because once you enter your work life, once your
Corporate
responsibility
life.
is, yeah, you will find it more difficult to take those risks. So I think get into that habit right now, and then it would become easier once you are further in life.
Okay, that's it. On this note, we would like to end this session. Sir, could you please join another link for 5 minutes after the session for review purposes, if you
Okay,
mind,
sure.
please? Okay, I'll send the mail, I'll mail you that. Okay, on this note, thanks everyone for attending this session and have a very good night, sir. Very pleasant day to you. Thank
Thank
you,
you.
everyone.
Thanks, everyone.
Thank you, sir.